Okay, welcome back. Let's look at the other side of the notes. 114. Is this 114? Oh yeah, 114. Anyway, this one is the side angle side similarity theorem. So the idea here is that if we have an angle that's congruent, just one, then we'll need the surrounding sides to prove that the triangles are similar. So if the corresponding sides of two triangles are proportional and the included angles are congruent, then the triangles are similar. So in this case, it says AB, which I'm just going to mark with my little S mark. Doesn't mean it's going to congruent. I just use that to show the corresponding side. That should be RT right there. So that's my scale factor. BC, this one, should correspond with ST. So if that proportion holds and we need the included angle would be the one that connects those two sides, B and T. So angle B is congruent to angle T. Then I know the two triangles are congruent, namely ABC, RTS is congruent to RTS. All right, well, let's try these theorems out in a few examples here below. So this one looks like it would be side angle side. So we know that the angles are congruent because they have the same measure. Let's check the sides. Now, we could check the proportions like we did before, or we could reduce these down if they do reduce. So 6 and 10 do reduce by 2, and so that would be 3 and that would be 5. So I'll just write them in there. And this one I'm going to divide by 3, I think, 9 and 15. So that would be 3 and 5 again. So yes, they're similar. So I don't know. I don't have labels, so if I want to make a statement, I better just say ABC and DEF. So triangle ABC is similar to triangle DEF. And if I want to find the scale factor, which I want you to do, that would be two corresponding sides. Let's use 6 and 9. So we could say 9 over 6. The other way would work too. And then let's divide those by 3. And so that equals 3 over 2. So that's my scale factor. So that's the first one. So on the second one, if we look at this and we'll need an angle, that one we knew an angle. This one, the only angle we could argue must be congruent is the vertical angles. Notice that that's not the included angle. So I don't know what that one is. So I would say we don't have enough information. Not enough info, and it's not the included side. The included angle. Included angle. Okay, now let's take a look at the third one. The third one, yeah, can we do this? Well, this time the vertical angle is the included angle. And if I reduce these down, divide this one by, it looks like I could divide by 9 because 9 goes into 18. So this becomes 3 divided by 9. This becomes 1. And this one over here, I could divide by 15. That's 15 goes in that once and goes into this twice. Oh, it looks like they're not similar, except I made a mistake. 18 divided by 9 is 2. Whoops. So there we have the sides that are the proportional now. So let's go ahead and write our statement. So triangle ABC is similar to this triangle, and A would, of course, correspond with D, triangle DEC. There it is. And then the scale factor for this one. So now we would have to use our original lengths, like 5 and 9, to make a scale factor of 15 and 9. So those correspond this way. So we could put 15 over 9 and divide by 3. We get 5 over 3. So the scale factor is 5 over 3. Okay, going quick, but that's okay. You could pause if you need to. Let's look at D And D, well, are those similar? I would say that they could be similar, although they don't look it. So let's go ahead and say this shared angle U is an angle, and then maybe we could get the sides that are similar. It's hard to visualize this, but to me, if these are going to be similar, it seems like this one right here would have to correspond with that one up there. Like this inside one is flipped over. So let's use 2 marks here. So let's go ahead and draw that out. So the first triangle is this way. I'll just redraw it. And I'm going to say this is U over here, and this is R and S. That's the one I marked with 2. That's the one that's marked with 1. I only marked this to keep track of it, actually. And the other one, this one is U. And if I flip it over, the V would go up there and the T would go down there. Okay, well, anyway, I probably shouldn't mark that because I really don't know that that's congruent, but it is corresponding to that one. Now, let's go ahead and put the numbers in. For the first one, this side right here, 4 plus 6 is 10. So the big triangle has 10, and 7 plus 5 is 12. So it's 10 and 12. And this one, this longer side from V to U is 6, and that goes up here, and the other one is 5. And it's looking to me like those are similar. If I reduce this by 2, divide by 2, I get 6 and 5, and so that does work. So now that they're this way, it's easier to write the similarity statement as well. So triangle RUS is similar to triangle TUV. Now, if I want to write the scale factor, I could use my original lengths. Let's use 5 and 10 right there. And so that would be 5 over 10 is 1/2. All right, well, that's it. Let's take a look really quick, a preview of the assignment that I gave you today, just to give you some heads up, because I noticed that this one has a decimal, and if you want to use this technique for this one, it's going to be harder because that's a decimal. So I'm going to just say, instead of dividing, I'm going to multiply this one by 10 just to get started with, because I want to get rid of that decimal. If I multiply it by 10, I could say this is 252, and this is 180, and this is 180. So I could just replace my 3 sides with this, and then I could now reduce this down. So I'm not sure that, well, what you could divide those by, but maybe you could divide them all by 18. I don't know. Or maybe you could divide them all by 4. Give it a go. These two are like the one that I didn't do on page 1. And then on the very end here, there's a challenge problem. You don't have to do this. I thought this was really challenging. So if you want to give this a go, give it a try. These two triangles, a hint, these two triangles side by side here are not similar. I think you do, for me, if you draw in a line down the center, you do create some other similar triangles that just kind of help you out. Let's go back to page 1. Yeah, I remember that I forgot to do this one problem on page 1, but I think we've done this before. It's basically find the value of x that makes these similar. And if that's true, then these proportions would hold. So let's just use the scale factor here. The scale factor, let's suppose we go that way, would be 12 over 4, which dividing by 3 would be, but dividing by 4 would be 3 over 1, 3 to 1. So that's my scale factor. Now I could pick some corresponding sides. I could say those right there. And let's see, so 3 over 1 would equal 18 over x minus 1, and I can solve this. So 3 times x minus 1 equals 1 times 18, and so 3x minus 3 equals 18. So I have 3x minus 3 equals 18, and adding 3, I get 3x equals 21. Divide by 3, and x equals 7. So that looks good. That makes this side 7 minus 1 is 6, and this side 7 plus 1 is 8. 8 times 3 is 24. Now I'm just going to go ahead and check my extended ratio here. If I divide these by 2, I'm just going to put them down here, 2 for this one, and this one would be divided by 2 is 3, and this one divided by 2 is 4. 2 to 3 to 4, 4 is my extended ratio. On this one, it looks like I could divide by 6 over here. So I've got my short side divided by 6 is 2. Next one divided by 6 is 3. And this one divided by 6 is 4. So these extended ratios now are the same. It's possible, I suppose, that I gave you a problem that the triangles can't be similar, like we found X and it didn't work out. We did find X, and it does make the triangles similar. So there you have it. I hope this helps. I'll talk to you when I get back to school. Hopefully that'll be Wednesday. I'll see you then.